Here we go. I'm Harold Leishman, Senior Investment Advisor with CG Wealth Management, speaking with Peter Londa of Tantalus. Truly a very interesting company. When utilities look to modernize their distribution grids, they can have the option to have your hardware incorporated directly into the new meters they deploy. And from this, you receive a hardware sale. On top of that, a perpetual software license sale and annual recurring revenue after that. That sounds like a phenomenal business. Trailing 12-month revenues around $43 million US. Can you discuss your core business, new customers, growth from existing customers? Why don't we start with that?
Yeah, absolutely. Good morning, everybody. Thanks for allocating some time. My name is Pete Londa. I have the privilege of serving as CEO of Tantalus Systems. Joined here today with our CFO, George Resnick, from our office in Burnaby, just outside of downtown, and with some assistance from Deb Honig, who supports our investor relations firm. So Deb, George, thanks for the support. So Tantalus is a technology company focused on innovating the electric distribution grid for utilities. Our customer is the utility, so we are a B2B company. As of the end of Q2, June 30th of this year, we reported that we now support 283 utilities, most of which are in the United States, with some in Canada and the Caribbean Basin. And what we predominantly do for those utilities is we help digitize existing assets and turn them into intelligent, communicating assets that deliver data into our enterprise software applications. And as we continue to expand and invest in R&D, AI-capable predictive data analytics. So at the very highest level, we are, a lot of folks, the easiest thing to focus in on is the meter. At the edge of the grid, that's the utility is sort of focused on the edge of the grid. Meters at a home, a business, or a commercial and industrial entity. And what we'll do in that circumstance is this is an example of the type of device. You see it on the screen here. If you opened up your iPhone or whatever mobile device you had in your hands, you'd find something like this. This is a computing device, custom ASIC, memory, both flash and RAM, communications capability. And once a utility inserts our device into a meter, as an example, we do it for a lot of other devices, as you can see. So we're not just in the metering business, but once our edge computer is integrated into a variety of different assets that the utility deploys, we start gathering information as it relates to consumption patterns, power quality. And from all of that data, we run it through a suite of enterprise software applications. As you can see at the top of the screen here, we're helping utilities educate consumers, helping utilities identify where power outages have unfolded and then how to restore power quickly. And with our predictive AI capabilities, helping utilities pinpoint where they have assets like a transformer that is about to fail, and try to go out and maintain or fix that transformer before it creates an outage or, even worse, explodes and creates a fire. So a lot of what we're doing ties to improving the resiliency, the reliability, and ultimately the efficiency of the utility. And we do this today for 283 utilities. And to Harold's point, trailing 12 months revenue as of June 30th is $43 million US.
Is there an ROI that you sort of have defined for clients? I know you offer a broad range of products and services, but is there sort of a baseline or?
Yeah, so everything that utilities do ties to a return on investment. They are CapEx-oriented organizations that purchase assets, put those assets in the field, depreciate those assets, and then replace or upgrade. And so depending on the suite of capabilities that utilities leverage from us, the device plus some software, the device plus software and analytics, as an example, the device plus software analytics and professional services, the ROI varies. But typically for utilities that just kind of, I'd say, sort of start with us. The ROI, we think of it in payback over years. It can range from 4 to 5 years. As utilities start to add in our analytics capability, that return on investment or number of years for payback reduces to 3 to 4 years. So it's when utilities are thinking about assets, just as an example, our device is typically in the field for 12 to 15 years. And so the payback on just basic functionality is about 5 years. So almost 3x return on the asset over 15 years of leveraging the technology.
That's got to be highly compelling for these institutions. For the last couple of years, you've invested quite heavily in TruSense Gateway in conjunction with some of your larger clients. And I love it when companies can have their clients direct R&D, say this is specifically the kind of product we want because you know you'll have a great consumer at the end. But are you coming close to the end of your R&D cycle for that product, or is that ongoing?
Yeah, so what Harold's referencing, for those of you that may follow us or start to follow us, we've been investing heavily in what we call the TruSense Gateway, which from an example perspective, I'll just hold it up so everyone has an appreciation. It's a device. The intent of this device is to plug into any existing meter socket on the side of a wall, home, business, and then a meter plugs into our device. So we say it's a socket-based device, meaning it sits between any existing meter and any existing meter socket. About 2 years ago, through our annual users conference, where we bring utilities and industry stakeholders and consultants together and members of our team, we saw an increase, and we run a survey every year in conjunction with our annual users conference. And we saw an increasing level of concern about the impact that electric vehicles would have on the integrity of the grid. And specifically, 2 years ago, Ford, a little more than 2 years ago, Ford in particular announced the F-150 Lightning. The F-150 pickup truck has been among the highest selling vehicles, passenger vehicles in the U.S. for some time. And the Lightning, the electric version of it, the extended range vehicle has a 19 kilowatt battery. That's effectively equivalent to a whole home backup generator on wheels. And so to charge that type of vehicle, to put this into layman's terms, when you plug an F-150 Lightning into a socket to charge, it's like adding 6 5-ton air conditioning units on the side of a home like that. And so when you think about average homes and air conditioning usage, especially during the summer months in the United States where we get a lot of heat and humidity, right, it's a real problem. And so when that type of load pattern comes on, obviously Tesla's smaller battery, smaller load, but when that type of load profile hits the grid, what does that mean for the utility? First and foremost, the expectation is that everyone's going to be able to charge those vehicles wherever and whenever they want. That's problem number one. The second issue is once a EV charger is connected into the distribution grid, right, it's got to have a meter on somewhere to meter the load. That meter socket is prone to heating up because more electricity is running through it. And as you back that up through the grid, right, incremental strain puts pressure on pole top mounted transformers and then distribution pad mounted transformers. And so as utilities are asset oriented and asset management oriented, the level of concern that was articulated to us from our user community really was a combination of, first and foremost, they have to figure out how to deliver more electricity to a variety and increasing number of places. And the second was the strain that would have on transformers. It happened to coincide when transformers, which normal course utilities run to failure, that is their methodology. It's archaic, but within that methodology, the expectation is they can always buy transformers. And about 2 years ago, you may all be well aware of the fact there was a pretty substantial supply chain constraint on components, sort of as a result of COVID-19. And so that started to seriously impact utilities' access to transformers. So on the one hand, they've got to prepare for more delivery of electricity, and on the other hand, they got to change their modus operandi of just running devices to failure because there's no guarantee they'll have inventory. And so it was that combination of two things, protecting assets and preparing for the future, that led to the construction of this device. And Harold, to your point, we pulled 8 utilities together, and then received interest from 2 utilities that haven't purchased anything from us ever, to form an advisory committee. Within our technology development cycle, hope is not a methodology for us relative to our size. And so we leveraged our advisory committee to design the TRUSense Gateway, and as of this morning announced through press release, the commencement of field trials of this device is the final process before it is fully commercial and available for sale later this year.
So sales end of this year on that product?
So orders by the end of this year for this product. And what we'll see is of the utilities in the advisory committee, some have already put this into the field. There are got it. Sorry, just caught that at the peripheral. Thanks, Jeff. You're advanced. No, that's great. No, thank you. Ahead of me, as usual. There are 3 versions of this device. The first version is for utilities that are deploying fiber all the way to the home or the building. There are about 200 utilities in the United States that are doing that today. And so this specific device is connecting a fiber node to the electric socket and an electric meter. And so the plan is to have this device now at all members of our advisory committee and field trial, with the intent of getting available for sale towards the end of November, early December timeframe, assuming no surprises. And from that, we'll see orders from members of the advisory committee in particular to start their phase 1 or phase 0 of rolling these out across their footprints.
And do you have any sense of how large that phase 1 might be and how long it would take to deploy? Obviously, you're talking about deploying, utility infrastructure, laying fiber, all that sort of thing, or hanging fiber on poles. It's time consuming and costly for the utilities. So what's the time frame?
So the aggregate opportunity that we've identified with the advisory committee members, the utilities that are helping us design and test this, it translates to almost $200 million revenue, $200 million US dollars of revenue opportunity for Tantalus. Our view is that we'll see that unfold over a 5 to 7 year timeframe. There are 2 other versions of this. There's an Ethernet version, and then there is a cellular version. The cellular version has a much wider market opportunity, and so we've got about 20 additional utilities that are engaging through our sales process today, some of which will be outside of our advisory committee, preparing for field trials of the cellular version of the device I have in front of me. The aggregate of those incremental 20 utilities translates to about another $750 million of opportunity. So the investment that we've made over the last 2 years has translated into about $1 billion of identified opportunity today over the next 5 to 7 years for Tantalus. The aggregate addressable market opportunity for this in the United States from some third-party groups that we've engaged is in the aggregate about $10 billion that we're chasing over the next 5 to 7 years.
And is there a similar revenue breakdown on those numbers where you're making a hardware sale, perpetual license sale, and then a recurring?
Yeah, so that model is pervasive within the utility industry. I've had the chance to meet with some investors that say, why not give the device away for free and then just charge a service-oriented SaaS concept? And while that's brilliant from a cash flow perspective, long-term, it's not the way utilities are regulated. It's not the way utilities are actually able to buy today. So this device will be sold with the base hardware, the device itself, a set of software capabilities that's kind of like the operating system on a PC or an iPhone. And from that, we'll get the sale of the device up front. That helps our cash flow near term, a perpetual software license for the base package of software to operate the device and use it, and then a recurring component, which is a 22% annual maintenance fee on the base software that's sold. Today, this device generates about $4 per device per year in recurring revenue, combination of maintenance and software licenses. The expectation is this device will generate about $10 per device per year over a 12 to 15 year horizon while it's deployed in the field. We haven't precisely locked down or communicated pricing, but order of magnitude, we're saying it's about a $500 device upfront, plus software license, plus then the $10 in recurring revenue per device per year per utility. So we see a great inflection point in our business to not only drive near-term revenue and cash flow from the device itself, creating high barrier to entry, and then just starting to scratch the surface on all of the software and the analytics that we can build from the data that we'll capture from this device.
And are you, it's a great business model, and are you adequately capitalized to fulfill that initial demand?
Yeah, so we've been pretty specific about that. We fortunately secured the support of EDC, Export Development Canada, Crown-based bank here in Canada, that provided us with a $7 million 6-year term loan. It's fairly favorable to our organization. That's sort of sitting to support near-term working capital requirements as we start to build inventory in anticipation of orders and field trials. And relative to cash on the balance sheet, plus the EDC facility that was put in place at the end of Q2 of this year, we're adequately capitalized to get us to the next phase of commercialization, phase 1, phase zeros. And then as we start to receive significant orders for long-term deployment, order of magnitude of tens of millions of dollars, we'll start to think about the broader capitalization of the company.
Right. Okay. And so this TRUSense Gateway, it's a new product. You're first to market with it. You've talked about the size of the opportunity, and you talk about behind the meter, and you touched on it earlier before with the lightning truck or whatever coming on. What other elements of household energy requirements, or does it expand to business as well, where the utilities want to see what's going on behind the meter, and how where can this go to, I guess, is the part of the question.
Yeah. So most places in Canada and the United States today, you'd be surprised at the number of utilities that really don't know what's happening beyond their substation. A substation, for those of you that don't understand or familiar with the utility industry, right? You'll see them in your neighborhoods. They're typically a lot of equipment, a lot of electric wires and chain link fence with barbed wire on top, with big signs, right? Do not enter, high voltage, things like that. Utilities typically have pretty good visibility to the substation. We like to say a lot of utilities are blind as to what's happening behind the substation. And Deb will jump to sort of that view, but right, they don't know when power is out more often than not until someone calls and complains. It happened. I live in the New York metropolitan area in Connecticut. Right? It's a very populated area. Eversource, publicly traded on the New York Stock Exchange, multi-billion-dollar market cap. Right? They have no clue when the power is off at my home until I call to complain. And think about any other sector in our world today where that's acceptable. And so what we're doing is some utilities, not Eversource, the one that supports my home, but the 283 utilities we support today, right? They have visibility now to what's happening at the meter. Is power on? Is it off? Is voltage and current constant? Is it fluctuating? What does it mean if it's fluctuating? And is that a problem with the asset, or is there a problem inside the home? As we think about the F-150 Lightning, and I can start to personalize this because I now own one and have it in my driveway, and it's awesome, by the way. It is an amazing piece of machinery that's a lot of fun to drive. But as I plug in and start to charge, right, the utility is going to have that problem of incremental draw, incremental heat at the meter socket, incremental stress on the lines, incremental stress on the pole top transformer across the street from my home. And so when we talk about behind the meter, it's not just getting a meter reading. It's not just knowing what voltage and current are at the meter. It's actually having visibility and command and control of the devices in my house. So some would say, well, why as an individual would I ever let the utility control things in my home? And the answer for that is they will economically incentivize that through rates. And in the event of imbalances between the supply of electricity or the demand of electricity, right, I'd much prefer to maybe lose control of my EV charger for 4 hours or 6 hours than have an outage in my house. And so we see utilities implementing what are called demand-side flexibility programs. Demand-side flexibility means controlling demand consumption, and from that control, actually being able to connect to devices. So this device has both Wi-Fi and something called PLC, power line communications capabilities. It sends a signal from the utility into the home directly to the EV charger. We're integrated right now and doing that with ChargePoint at a utility today, where the utility can monitor and regulate the amount of power being consumed, the voltage and current going to that charger, and being able to predict and from that actually manage what's happening with the charger. Through partnership with Savant, home automation company, we're integrating very smart, intelligent circuit breakers so utilities can actually pinpoint certain assets in the home to reduce the amount of load on their system. And we are working with GE Appliances on their new water heating system at the residential level, where a utility could preheat water in anticipation of a storm, expecting power outages as an example, or preheat that hot water heater and then turn the hot water heater off, assuming it's an electric water heater, right, for a period of time when we have peak demand in the United States in places like Texas. So that's what we talk about behind the meter. It is extending the edge of the grid, and it is giving utilities much more granular control over what assets are working, how much energy is being consumed, and how to better manage their grid.
I see we've got 5 minutes left. Just check and see if people have questions. If not, I've got one. There's a question. Oh.
I'm sorry, I couldn't Are smart meters illegal? Oh, sorry. Yeah. So actually with our technology, we can pinpoint anomalies between what the meter reads versus how much energy is being consumed. So the polite way of saying it is non-technical loss. And we're able to help utilities pinpoint precisely where that non-technical loss or theft is unfolding.
Right.
Yep. Or illegal grow houses, right, as an example. Yeah, becoming less of an issue in certain states in the United States, but certainly we can pinpoint things like that.
Right.
Very much so. So be careful. I'm coming after you. I'm just kidding.
Anything on quality of life of product, how long it would last, or replacement costs, or how reliable it's been up to this point?
Yeah. So within the devices, the device I'm holding in my hand, we've been deploying a version of this since 2013 is when the first version of this Linux operating system went into the field. A significant number of these are still in the field operating. The design life for us, we say, is 12 to 15 years, depending on environment. You know, high humid environment versus cold weather. Electronics behave differently, and you know, we track in warranty returns. Our in warranty return rate is less than 0.5%, so we are pretty reliable. Yep. We always see some anomalies in utilities, and we see most utilities start thinking about replacement, some at 8 years and most at 12 years.
Shock or
So we do an awful lot trying to make sure utilities have proper grounding on their systems and do everything that we can to protect individual assets when a lightning strike hits. Sometimes when that happens, it's just, there's only so much you can do to protect the system. In that circumstance, we have a replacement program for utilities and extended warranty options as well that they can buy.
All right, looks like we're down to the last minute. As an investor, your revenue's been growing at a very nice clip, and recurring revenue is growing at 20+%. The value of your company, your relatively new public company, has come down almost in inverse to your revenue going up, which as an investor I find attractive. And EBITDA looks like it's trending towards being positive. Do you think you're going to get there in the short term, or?
Yeah, within the revenue profile today, roughly 25% of our revenue is recurring revenue. 35% is software and services. So 35% is software services. Of that 35%, 25% of total revenue is recurring. Leading up to going public and before we started investing in the TruSense Gateway, we were EBITDA positive for 18 consecutive quarters. We've invested over $8 million in this device over the last 2 years. If we were not moving on the TruSense Gateway, we would have been consistently EBITDA positive, and we are on the path to getting back there as we start to put these in the field and commercialize.
Perfect. Hey, thank you very much for your time. I think they're going to pull the plug here. So
no pun
intended. Thanks.
And for full disclosure, Harold Leishman is not a shareholder of Tantalus.